This is Cheryl Bisinunlay, now here to report about hypothesis testing. So, I'll give you such a brief hypothesis testing. Many of us would ask the significance about this topic. Ang unsay mabuhatan ni sa atong kinabuhi. So, researchers are interested in answering many types of questions. When we say researchers are the people. So, kita po mag-research man ta about some topics about sa ato ang courses, magamit nato ni siya sa ato ang on how to compute the outcomes sa atong datas. For example, a physician might want to know whether a new medication will lower a person's blood. So, kana nga unsa na kana nga question kay can be addressed through statistical hypothesis testing. It is a decision-making process for evaluating claims about a population. For example, a new medication will lower a person's blood or ma-reject ba na nato nga hypothesis or dili. So, we'll move to my topic. Steps in hypothesis testing. Every hypothesis testing situations begins with a statement of a hypothesis. As what I've said kanina, katong a new medication will lower a person's blood. A person's blood kay muna siya ang hypothesis nga kana bitaw siya ang imuhang himuog roots imuhang sa imuhang kahoy nga daghan din kag studies nga mabuhat. First, statistical hypothesis. A statistical hypothesis is a statement or assumption made about a population or a statistical model. It is used to test the validity of a claim or to make inferences about the population based on the sample data. Hypothesis testing is an essential part of statistical analysis and helps to draw conclusions about the population. So, kini siya na ani siya duha ka hypothesis no, ang statistical hypothesis, which is the null hypothesis and alternative hypothesis. Now, first, we'll tackle about null hypothesis. The null hypothesis, denoted as H sub O, is a statement of no effect or no difference between variables. It assumes that there is no relationship or difference between the variable being studied. The null hypothesis is typically the hypothesis that is tested against an alternative hypothesis. In hypothesis testing, the goal is to either reject or fail to reject the null hypothesis based on evidence from the sample data. From the given nga null hypothesis, na siya ginaingon nga. For example, the test is 82% of the students would ana. So, imuhang claims ana. So, the null hypothesis is equal to 82% of people. So, next, alternative hypothesis. The alternative hypothesis denoted as H sub alpha or H sub 1 is a statement that contradicts or opposes the null hypothesis. It suggests that there is a relationship or difference between the variables being studied. The alternative hypothesis is what researchers are trying to find evidence for. And if there is enough evidence, the null hypothesis is rejected for favor of the alternative hypothesis. So, akong example ganina katong the null hypothesis katong 82% of the katong studies nga 82 students kay na lower ang person's blood sa. So, if there's a claim nga 82 students are academically good, so ang iyang null hypothesis kay 82 ay null hypothesis is equal to 82 students. Pero pag alternative hypothesis, pwede siya nga the alternative hypothesis is not equal to 82%. It could be mas higher or lower. So, this is an example. Situation A. A medical researcher is interested in finding out whether a new medication will have any undesirable side effect. So, the researcher is particularly concerned with the pulse rate of the patients who take the medications. Will the pulse rate increases or decreases, or remain unchanged after a patient takes the medication? Since the researchers know that the mean pulse rate for the population under the study is 82 beats per minute, the hypotheses for the situations are the null hypothesis, the iyang mean kay is equal to, as what I've said, 82, and the alternative hypothesis, iyang mean kay is not equal to 82%. The null hypothesis specifies that the mean will remain unchanged, so equal to 82 the Japan. And the alternative hypothesis states that it will be different. This test is called two-tailed test, a term that will be formally defined later in this section, since the possible side effects of the medicine could be raise or lower the pulse rate. So, mong siyang gibutang og two-tailed kay it could be lower or higher. Situation B. Example. A chemist invents an additive to increase the life of an automobile battery. If the mean lifetime of the automobile battery without the additive is 36 months, then the hypotheses are the null hypothesis is equal to 36 and the alternative hypothesis mean is greater than 36. So ato ang ma-ask why nganong dili yang ang gigamit nga claim sa alternative hypothesis is greater than, dili siya katong not equal to. So in this situation, the chemist is interested only in increasing lifetime of the batteries. So her alternative hypothesis is that the mean is greater than 36 months. The null hypothesis is the mean is equal to 36. The test is called the right-tailed since the interest is an increase only. So right-tailed siya. Right-tailed test kung ga-increasing or ihang claim is greater than or something like. Pero pag not equal to ihang test, ihang ginatawag na to og two-tailed test. Just situation C. A contractor wishes to lower heating bills by using special type of insulation. A contractor wishes to lower heating bills by using a special type of insulation in houses. If the average of the monthly heating bills is $78, her hypothesis about heating costs with the use of insulations are null hypothesis mean is equal to $78 and alternative mean is less than $78. This test is left-tailed test since the constructor is interested only in lowering heating cost. So kung na siya possibilities nga mag-decrease or increase, two-tailed test. Pero pag focus lang siya on increasing dakuan, right-tailed. Pero pag decrease lang siya, left-tailed. So to state hypothesis correctly, researchers must translate the conjecture or claim from words into mathematical symbols. The basic symbols used are as follows: equal to, not equal to, greater than, and less than. The null hypothesis, alternative hypothesis are stated together, and the null hypothesis contains the equal sign as known, where k represents a specific number. Two-tailed test, makita man nato, two-tailed test kung imuhang alternative hypothesis kay not equal to number. Right-tailed test kung imuhang kwan is greater than, imuhang alternative test lang ta magkuan ha, is greater than. Left-tailed test pag imuhang alternative hypothesis mean is less than. Hypothesis testing common pair. So mo ni siya ang mga kuan ni mga ang ato ang claim sa ato ang alternative hypothesis kay nani siya ang mga words is greater than, is above, has higher than, longer than, bigger than, increased. Mo ni siya ang right-tailed test. Pag left-tailed test kay is less than, below, lower than, shorter than, smaller than, decreased or reduced from. Is equal to, mo ni siya ang sa null hypothesis is equal to, the same as, has not changed from, the same as. Sa right-tailed test, ano siyang is not equal to, is different from, has changed from, is not the same as. Mo ni siya ang from mathematical equations to in a words. Statistical test. A statistical test, also known as hypothesis test, is a method used in statistics to make difference about population based on sample data. It is used to determine the likelihood of observing certain outcomes or difference between groups under specific set of assumptions. Kining statistical test mo ni siya ang mag-reject or magkuan sa or ginakuan niya ang null hypothesis, ma-reject niya or i-accept niya ang null hypothesis. In hypothesis testing, naa siya upad ka possible outcomes. In reality, the null hypothesis may or not be true. So, ang hypothesis ma-reject mo na siya theories. And the decision is made to reject or not reject it on the basis of the data obtained from sample. Muna siyang 4 possible outcomes: type 1 error, correct decision, type 2 error. 2 possibilities for correct decision kung imong ima-reject nimo or dili nimo i-reject ang hypothesis. Tapos 2 possibilities for an incorrect decision. Mano siyang gitawag na tog type 1 error kung i-reject nimo ang hypothesis which is true. Type 2 error kung na dili nimo i-reject ang null hypothesis which is false. Okay, type 1. Type 1 error is the incorrect rejection of true null hypothesis, while type 2 error is the failure to reject a false null hypothesis. Both errors are inherent in hypothesis testing and represents the trade-off between making correct decisions and the risk of making incorrect decision based in sample data. A level of significance, denoted as alpha, is a predetermined threshold used in hypothesis testing to determine the critical region. It represents the maximum probability of making type 1 error, which is incorrect rejection of true null hypothesis. Second, the probability of type 2 error is symbolized by B, the Greek letter of beta. In most hypothesis testing situations, B cannot be easily computed. However, A and B are related in that decreasing and increasing the other. So, para minimize lang nato ang risks, both type 1 error and type 2 errors, we the researchers need to carefully consider the appropriate need of significance of alpha and the power beta based in the specific context requirements of the study. Strike a balance between those 2 errors to ensure accurate and reliable data. Kay kung magkamali man gud sa ato ang magkamali ta sa ato ang research, samot nag ato ang gina-research is about medicines, no, kay maka-apekto jud dako sa ato ang mga patients. So, there are 3 arbitrary significance sa significant levels: 0.10, 0.05 and 0.01. Mo ni siya ang levels of the type 1 error. So, kining 0. There's a chance that it will be rejected. Mo ni siya ang mga null hypothesis. Pag maka-came up ka og 0.10 nga result, there's a chance that it will be rejected 10%. Pero pag 0.05, 5%, and 0.001 is 1%. The critical value separates the critical region from non-critical region. The critical or muna siya ang critical value, muna siyang sa ato ang graph, no, pag mag-graphing na about si hypothesis kana siya, critical value mo separate sa critical region from non-critical region. Makita na nato niya. So, the non-critical or rejection region is the range of values of the test that indicates that there is significant difference and that the null hypothesis should be rejected. The non-critical or non-rejection region is the range of values of the test value that indicates that the difference was probably due to chance and that will the null hypothesis should not be rejected. So, ang critical value mo na siya silbi bridge ni siya sa critical o non-critical regions. Nga, mo ni siya dire hati tiga hati. So, the critical value can be the right side of the mean or in the left side of the mean for one-tailed test. Its location depends on the inequality sign of the alternative hypothesis testing. So, sa ato man jong sa ato ang table sa ato ang graph makita man dyan na siya x-axis, y-axis. So, kung left-tailed siya, na, syempre, dito jud siya mabutang sa, sa left side, which is the negative value sa x. Pero pag right-tailed siya, dito siya dapito sa positive value sa x. Ano siya? Finding the critical value for an alpha is equal to 0.01 right-tailed test. Nga nung makaingon tag right-tailed test because naman siya dapita sa positive value sa mga x's. As what I've said earlier, critical region kini siya ang kaning pa-curve. Taga-separate sa kaning pa-curve. Critical region mo ni siya ang pag-reject sa null hypothesis. Pag naanatay nga nga mga data sa tuang B, mo siyang B critical region. Sa B, sa critical value from table A, mo siyang find this area table as shown. Closest value to to obtain the critical value, the researcher must choose an alpha level. In situation B, suppose the researcher chose a 0.01 as what I've said, the 3 arbitrary significance levels, yang gipili kay 0.01, then the researcher must find an z value that 1% of the area falls to the right of z value and 99 falls to the left side of z value, as shown in 8-4. Next, the researcher must find the area value in table A closest to 0.9 and the critical z value is 2.33. Haman ano nakita ang 2.33 balik ta sa tong kwan. From this 2.3 ihada yung kwan sa babaw ihang x axis kay 0.03. Ikuan mo na silang duha is makakame up kag 2.33. As shown here. The critical and non-critical regions and the critical value are the shown in figure 8 to 5. Muna siya ang non-critical region. And that's all.
Mundo, the reporter of GTs for proportions. Many hypothesis testing involve proportions. From previous terms of statistics, we know that the proportion is the same as a percentage of the populations. In hypothesis tests involved a population proportions. There are only in two outcomes and the probability of a success does not change from trial to trial. So let's move the formula of G-test for proportion. G equals P hat minus P over square root P Q over N. Whereas P hat equals X over N, and this is a sample proportion. P is a population proportion, and N is a sample size. So P hat from the sample value is observed values, and P is the expected value And this is a hypothesized population proportion. And square root PQ over N, and this is a standard error. Example, people are trying to avoid trans fats. Dietitians claims that 60% of people are trying to avoid trans fats in their diets. And she randomly 200 people and found that 128 people state that they were trying to avoid trans fats in their diets. At A equals 0.5, is there enough evidence to reject the dietitian's claims? So let's solve step by step. So step 1, state the hypothesis and identify the claims. So since the null hypothesis P was 0.60%, and this is a claim. And alternative hypothesis P 0.60%. Step 2. Step 2 is find the critical value. Since A was 0.05 and the critical value is total. So the critical value is the critical value are 1.96. A over 2 equals 0.025. 175. So let's move the step 2. Step 3. Step 3 is compute that is value. First, it is necessary to find p hat. P hat was x over n equals 128 over 200 equals 0.64. And the q was, no, the p was 0.60 and q is 0.60 equals 0.40. So substitute in the formula. P hat G equals over squared PQ over N. So 0.60 64 minus P 0.60 over square of P 0.60, and the Q is 0.40 over 200. 200 is N. So equals 1.15. So this is step 3. For step 4, make the decisions and do not reject the null hypothesis since that this value falls outside the critical regions. So let's draw the this one is negative 1.96 and one is negative 1.96 and 15. So as you can see, no nga. So first step 5 is summarize the results. Is there is not enough evidence to reject the claims that 60% of people are trying to avoid trans fats in their diets. Another example, advertisement. An attorney claims that more than 25% of all lawyers advertise. A sample of 200 lawyers in a certain city showed that 63 had used some form of advertising. At E equals 0.05, is there enough evidence to support the attorney's claims? So use the p-values method. So step 1 is state the hypothesis and find the claims. So null hypothesis p equals 0.25, and an alternative hypothesis is p greater than 0.25, and this is a claim. For the step 2 is compute the test values. So p hat equals x over n equals 63 over 200 equals 0.315, and p equals 0.25, and q 1 equals 0.75, and g equals p hat minus p over square root of pq over n. Then substitute so 0.315 minus 0.25 over square root of 10, square root of 0.25, 0.75 over 200 equals 2.12. So the step 3, find the p values. The area under the curve for G is 2.25, is 0.9830. Use normal distribution table. So subtracting the area from 1.000 minus 0.9830. So the p value is 0.0170. So let's move the step 4. So the p value is 0.0170. And the step 4 is reject the null hypothesis since 0.0170 is than 0.05. And that is a p value. P value is 0.05. So the step 5 is so the step 5 is 0.25. area of area 0, 1, 0, 1, 0, and area of 0.05. So, as you can see for the step 5, there is enough evidence to support the attorney's claims that more than 25% of the lawyers use some forms of advertising.
Good day everyone, I'm Corazon Simini and I am going to discuss the Z-test for the mean. So Z-test is a statistical test for the mean of a population. It can be used when n is greater than equal 30 or when the population is normally distributed or population standard deviation is known. So, mao ni ang iyahang formula sa Z-test. Z is equals to sample mean minus hypothesized population over reject the null hypothesis. 5. Summarize the result. So, this is the example solution of the Z-test mean. Number 1 is HO and hypothesis population is equals on 29. And the second is H1, hypothesis population is greater 29. So magpili ka dinhi kung unsa tong pangita sa problem. So ang gipangita niya is kung asa ang greater than 29 days. So ang atong claim ani is H1 hypothesis population is greater than 29 mo ni ato ang claims. So number 2, so hence the population standard is equal on 0.05 and the test is a right-tailed test, na siya sa right-tailed. So the critical value is Z is equals on positive 1.65. So mo ni atong pangitaon kung mo ni atong basihan kung unsa ba siya na reject ba ang ato ang claims or wala. So number 3 is mag-solving ta sa ato ang problem. So Z is equals X minus hypothesis population, standard deviation, and sample size. So dere atong isulat atong given. So 30.1 minus 29 over 3.8 divided by 30, so equals 1.1 divided by 3.8 divide 5.48 is equals kapihon lang sa babaw, then imo ning i-divide din sa ubos mo ni ang result 0.69. So ang result nato ang Z-test nato is 1.59. So number 4 is the making decision. So mo ni ang pattern sa ato ang solution. So diri nabutang is a percentage niya is 0.9500. 0 sa ubos. Diri nabutang is not rejected. Ang diri nga side is rejected. Taman siya sa 1.65. Dili na ito mabalaan kung na-reject ang atong claims or wala siya na-reject. So, ang ipangita na to is 165. So, ang atong result sa Z-test is 159. Wala man siya naabot sa 165. So, ang ato ang claim is wala siya na-reject sa ato ang claims. So, ang atong number 5 is the summarize. There is not enough evidence to support the claims that the mean is greater than 29. So dili nato mabalan kung not rejected siya or rejected ba siya. So ang ato ang claims is nagpamatuod nga dili siya rejected kay nakasulod pa man siya sa not reject. Next is the p-value. P-value means probability value. This is the probability of getting a sample statistics or a more extreme sample statistics in the direction of the alternative hypothesis when the null hypothesis is true. This was the solution of the p-value. So parihara gyapon og pattern dito sa D-test. So number 1, pangitaon ang claims kung unsa ba siya, equal 8 ba siya or not equal to 8. So number 2, z is equals 8.2 minus 8 over 0.6 divided by the square root of 32. So ang equals ani is 1.889. So ang atong z ani, z test is 1.89. Nag-equivalent siya og 0.9708. So kani siya ang ato ang kuan critical value is dili ani siya critical value kuan na dili siya p value, i-subtract nato sa 1.0000. So nadiri 1.000 minus 0.9706 is equals to 0.0294. So note lang ta nga kung duha ka tail ang magamit nato, i-double ra nato ang ato ang value. So i-times nato atong value. I-times sa 2 times 0.0294 is equal 0.0588. So making decision nara ang pattern aron mabalan nato kung reject pa atong pattern or dili. So nabutang nako diri ang katong gi-times ka ganina nga double nato kay duha man ka tail ang gigamit, so 0.025. Ang original nato nga pattern is 0.0294. So naa siya diri, nakasulod siya sa 8.2. So ang atong summary is not enough evidence to reject the claim that the average wind speed is 8 miles per hour. So dili siya kuan nga ebidensya nga kani siya reject ang ato ang claims. So diri na punta sa t-test for the mean. T-test is the statistical test for the mean of the population, o ginagamit lang ni siya kung normal or approximately normal ang distributed sa atong sa standard deviation. So mo ni ang formula pareha ra gyapon, ang nakalahi lang is ang primero diri ang z, karon is t ato ang gamit. So pareha ra siya nga pattern, nalang siya na additional na the degree of freedom. Mo ni siya ang na-additional sa iyahang pattern.
Chi-square test for variance or standard deviation. In Chapter 7, the chi-square distribution was used to construct a confidence interval for a single variance or standard deviation. This distribution is also used to test claim about a single variance or standard deviation. To find the area under the chi-square distribution, use table G in Appendix C. There are 3 cases to consider. So these are the objectives in this topic. Finding the chi-square critical value for a specific alpha when the hypothesis test is right-tailed. Finding the chi-square critical value for a specific alpha when the hypothesis test is left-tailed. Finding the chi-square critical values for a specific alpha when the hypothesis test is two-tailed. So this is the first objective. Find the critical chi-square value for 15 degrees of freedom when alpha is equal to 0.05 and the test is right-tailed. The distribution is shown in 8 to 30. Muna siya. So, muna siya ang graph. Degrees of freedom. Ipangayon niya ang 15 degrees ganin na. Tapos, ang alpha niya kay 0.05. For find the value of the top table of G and the corresponding degrees of freedom in the left column. The critical value is located where the two columns meet. In the case of 24.996, muna siya ang value. Now, second, let's move on to the second objectives. This is define the critical chi-square value for 10 degrees of freedom when alpha is 0.05 and the test is left-tailed. Ganina kay right-tailed, dire kay left-tailed na pod. When the test is left-tailed, the alpha value must be subtracted from 1. That is, 1 minus 0.05 ang katong alpha na to ang gipangita ganina kay gi-minus 1 minus alpha is equal to 0.95. The left side of table is used because the chi-square table gives the area to the right of the critical value and the chi-square statistics cannot be negative. The table is set up so that it gives the values for the area to be right of the critical value. In this case, 95% of the area will be the right of the value. For 0.95 and 10 degrees of freedom, the critical value is 3.940. Muna siya ang kuan. Find the critical chi-square values for 22 degrees of freedom when alpha is 0.05 and two-tailed test is conducted. So, muna siya ang when a two-tailed test is conducted, the area must be split as shown in figure. Muna siya. Note that the area to the right of the larger value is 0.025. 0.05 divided by 2 or alpha divided by 2. And the area to the right of the smaller value is 0.975. 1 minus 0.05 divided 2 or 1 minus alpha divided by 2. Muna siya ang came up niya nga critical value. Remember that the chi-square values cannot be negative. Hence, you must use A values in the table of 0.025 and 0.975 with 22 degrees of freedom. The critical values are 36.781 and 10.982 respectively. Muna siya ang came up man siyang critical value sa one. And that's all.